Hello, welcome to Zigmatech Learning Hub. I will be your instructor for chemistry. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device or on your phone, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, JCE, KCPE, IJMB, JUPEB, Calbepedia, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. Yeah, thank you. Welcome. Today we are going to be talking about particles of matter part 2. Remember we talked about particles of matter part 1 when we talked about the atoms. We said the particles of matter are 3, which are the atoms, ions, and the molecules. Today, we are going to be talking about the part 2 of the particles of matter. Now, by the end of this lesson, you will know about ions, differences and similarities between ions and atoms. Now, first of all, as you can see on your screen, the charges are going around. The charges are going around hitting themselves in order to bring forth an electric charge. Okay, now an ion, first of all, was talked about or was discovered by Michael Faraday in 1834. That same year was the year he made electricity viable for us to use, using the experimentations of Benjamin Franklin and Humphrey Davy. You know, Benjamin Franklin used the kite, the storm, and a key to identify the cations and the anions, which are the types of ions. Now, Michael Faraday, using an electrical dynamo is a crude generator. A generator is an apparatus or an object that converts mechanical energy to electrical energy. So that's what he used in identifying ions, in bringing out ions. Because knowing fully well that electricity has charges, which are the ions, he knew that these two charges must have to repel. Okay? They must have to be in opposite direction for them to give us a free flow of electrical current. So take note, the ions was discovered by Michael Faraday in 1834. Now, definition of an ion. Okay? Now, before we define an ion, let us know how this ion is operating. Let's know how this ion came about. I told you that the atom is the main particle of matter. Okay, the atom is the main particle of matter. Now, from the atom we get the ions, and still from the atom we get the molecules. We know that these are the 3 particles of matter: the atoms, the molecules, and the ions. Now, this is an atom. Okay, let's take for example this is an atom. Now, this is the proton. This is the neutron, and this is the electron. I told you that in the proton, okay, this H superscript plus is hydrogen ion. And we know that hydrogen ion are also called protons, according to William Prundt. Okay, when he gave the name hydrogen ion to proton, according to William Prundt and Eugene Goldstein. I told you that when we were talking about the protons. Now, the electrons, having known the electrons is, if the electron is H subscript minus or OH superscript minus, superscript minus. Now, looking at the structure of this atom, the atom has 3 particles. And if you check, it has only 2 charges, the protons and the electrons, of which you know. I told you about that when we were talking about the atoms. Now, these two charges in the atom, is called the ion. The two charges in the atom is called the ion. Now, if they ask you a question that what are the two charges in the atom? What are the two charges in the atom? You don't tell them the ion. You tell them it is the protons and the electrons. But if they ask you the two charges in the atom is called the ion. Is a singular, are plural. Now, when you're identifying it independently, the charges are the protons and the electrons. This H plus signifies hydrogen ion, and the H minus signifies hydroxide ion. Hydroxide ion. Now, hydrogen is the only element that is being used to identify charges. Why? Because when the protons was discovered by Lord Ernest Rutherford, theoretized by William Prout, like I said, and the evidence that hydrogen ion is called, a proton is called hydrogen ion by Eugene Einstein. When J.J. Thomson wanted to discover the electrons, he knew that if the hydrogen has a positive sign, that means to say it must have to have a negative. It must have to have a negative. Before James Chadwick came and knew that if the hydrogen has a positive and it has a negative, it must have to have a middle, which is a neutral. We talked about that in the atom. Now, looking at this structure, okay, we have two charges. The positive sign, which is the proton, and the negative, which is the electron. These are the two charges. And these two charges are called the ions. It's called the ions. Now, this H, that is this is the molecule. Okay? This is the molecule. So in that sense, we've gotten the atom, the two charges, which is the ion, and the molecule. When we get there, we'll talk about the molecule more. Now, I told you that the atom is electrically neutral. Why? Because it has the same number of protons and electrons. If you look at your screen, you will know what I'm talking about. Okay? Now, this particular ion is still an atom. Why? Because the ions came out from the atom. If you check, the charges in the atom is called the ions. Now, the ions came out from the atom. Your father gave birth to you, which means his DNA runs in you. You are your father, but your father is not you. In essence, these ions is an atom, but the atom is not an ion. The ions are species of an atom. The ions are particles of an atom. Okay? The ions are the children of an atom. In essence, it is the atom that gave birth to the ions. Why? Because the particles, the children of this atom, is called an ion. Now, what is an ion? We said an ion is an atom or a group of atoms with a net electric charge. In essence, the charges in the atom is the ion. Now, this atom we're talking about has a neutral charge. How do they get charged? Okay, how do they get charged? Now, if you look, you see neutral atom. The first arrow goes to the cation, which says loss of electrons, and the other one says gain of electrons. Now, for this atom to get a charge, it must have to lose or gain. For this atom to get a charge, it must have to lose or gain. Why? Because it has the same number of protons and electrons. So for him to have a negative charge, he must have to lose the positive charge, so that the negative will be bigger than the positive for him to be negatively charged. And for him to have a positive charge, he must have to lose the negative, so that the positive will be bigger than the negative. Let's say he loses two electrons. Okay? In essence, the number of protons and electrons will not be the same. Why? Because 2 electrons have been lost, and it has been added to the proton. In essence, the proton will be 2 charged ahead of the electron. So, for that process, where the atom gains electric charge, okay, by losing or gaining electrons, is called ionization. is called ionization. Ionization there is the process of charges. Okay? The ionization means the process of charges, the surrounding of charges, the organization of charges. So for the atom or molecule, okay, because the atoms and molecules are the same when it comes to charges. They are electrically neutral, both of them. So for the atoms and molecules to gain or lose electron, to gain electric charge by losing or gaining electrons is called ionization. So ionization is a process whereby atoms or molecules gain electric charge by losing or gaining electrons. By losing or gaining electrons. Take note. Now, types of an ion. Types of an ion. There are two types of an ion. We have the cations and the anions. We have the cations and the anions. The cation is an ionic species with a positive charge. In essence, the cation is the protons. The cation is the hydrogen ion. Now, that positive charge, you see at the superscript, is the charge of the hydrogen. Okay? That particular positive sign you see represents the charge. Okay? And anions is an ionic species with a negative charge. In essence, the anions are electrons. The anions are electrons. Now, sorry, I didn't tell you something when I was talking about the ionization. Now, remember, I told you that the atoms must have to gain charge through ionization, okay, when he loses and gains. Now, for him to lose, an electron will be removed from the atom. Or for him to gain, an electron will be removed from the atom. Electron in that particular phase is called the charges. Okay? If you're identifying it independently, then you separate the charges as protons and electrons. But if it is not independently identified, anywhere you hear electrons, they're talking about the ions, the free flow of ions. They're talking about the electric charges. It's a simple mathematics. When you say H subscript D plus this, it will give you this. Okay? Now, this H minus is hydroxide ion. Either you write it like this or OH minus. Now, for that electron to leave the atom, it takes an energy. Okay? And energy must be used to remove. Because without energy, there will be no force. And without force, there will be no movement. That's the work done. So in essence, the energy required to remove an electron from an isolated atom or molecule is called ionization energy or ionization potential. Potential is the same as energy, the stored energy. Okay? That energy that is being stored in an ion is called ionization potential. Now, the process or the energy required to remove an ion from an atom or molecule is called ionization energy. Only then ionization will occur. Only then ionization will occur. Because if the electron is not being removed, there will be no charge. The electron might be positive or negative. Take note. Now, we have cations and anions. Okay? Now, this cations is an ionic species with a positive charge. Now, you're seeing that this particular thing has a positive charge. Okay? And in essence, the cations are protons. They're the positive charge part of an ion. Okay? Now, a cation with a +2 charge, let's take an example, with a +2 charge, is called a dication. Di means two, as we know. A cation with a +2 charge, is called dication. In essence, dication means two electrons have been lost. Two electrons have been lost. In essence, it will make the electrons and the protons the same. Two electrons have been lost. So in that context, remember in the atom, they have the same positive and negative charge, the same number. So if the protons of the atom is 10, and the electrons of the atom is 10, and this particular substance has +2 charge, okay, this is the proton, and this is the electron. And this particular atom has +2 charge, okay, and it means that this +2 means 2 electrons have been lost in the atom. Now, these 2 electrons have been lost in the atom. It will now come to the proton, making it 12 protons and 10 electrons. In that context, the protons is now bigger than the electron, and the atom will have a positive charge. Now, an atom again with -2 is called dianion. The same thing goes. It means that this -2 means the atom has lost 2 electrons. That's lost 2 electrons, and it will still go back, vice versa. So, having knowing this, we know the dication and the dianion. Okay? So, do not get confused when you see a question like this. Now, the size of an ion. The size of an ion. What is the size of an ion? The size of an ion is influenced by the nuclear charge, number of electrons, and the valence orbitals. We talked about the nuclear charge. You know, nuclear charge comes from the nucleus of an atom. Okay? The number of electrons, in essence, the number of charges, depending on the size of an ion. Let's take, for example, iron. Iron has, now, if you're representing this charge with an element, you don't write +2. What you write is 2+. Okay? You do not write this, you write this. If you are representing a diion, a dication with an element, this is the charge. Okay? Iron has it, the magnesium has it, copper has it. Now, the dication, the dianion, oxygen has it. You do not write like this. It is written like this, like I told you. Okay? Now, the number of electrons, okay, in this ion is 2. Now, it is the number of electrons that will tell us the size of the ion in this. Okay? The size of an ion is not specific. It depends on the number of electrons that is being contained in the atom. It depends on the number of electrons that is being contained in the element you're talking about. Okay? Now, the nuclear charge comes. When the nuclear charge comes, remember, the nuclear charge makes the protons and the electrons to come together to form what they call a nuclear film. They form a nucleus film, sorry. Okay? A neutron film, neutron. They form a neutron film. So when both of them come together and form a neutron film, why? They will become electrically neutral in the atom because both of them have the same number of protons and electrons. So when the charge comes out from the nucleus of an atom, and this neutron film is being formed, we can know the size of an ion at that particular point in time. The size can be indicated. Okay? Now, the number of electrons is on the element or inside the atom. Why the valence orbitals? You know, I told you about the valence orbitals when we talked about the electrons. Okay? That's outer part. Okay? That the electrons is being rolling. The outer part, the outer shell of the atom, okay, becomes the valence orbital of the electron. Is still, that is where the valence electrons do their playing. Okay, they go around the atom, they go around the neutron, they go around the nucleus of an atom at the outer shell. That area is called the valence orbital. Orbital is just a space of movement. So these three things is these three things influences the size of an ion. The nuclear charge that comes from an atom, The number of electrons, like I gave to you, and the valence orbital. How do they move? Okay? How do they move? Their energy, the energy they have in moving. Okay, that energy they have in moving for them to react with the proton to bring a charge is still influenced by the size of an ion. Let's go to the principle of an ion. Okay, the principle of an ion states that as the principal quantum increases, the size of both the parent atom and the ion will increase. Remember, the ion is inside the atom. So anything that affects the atom will have to affect the ion. I told you a principal quantum. I've told you a principal quantum. I talked about the atoms and thereabout. So if this principal quantum increases, okay, the size of both the parent atom and the ion will increase. Why? Because anything that affects the atom will affect the ion, because the ion is inside the atom. Remember, if you're getting fat, okay, and your hands will be getting fat, your electrical part of your body will definitely be getting fat. Why? Because these things are with you. These things are part of you. These things are your body. Okay? So the same thing as the atom. The parent atom that has this ion inside, as they're increasing, the ions will increase. And remember, as the ions are increasing, their sizes are increasing. What makes their size to increase, like I said, is the nuclear charge. When nuclear charge comes out, it will increase the atom and the ion will increase. The valence electrons or the valence orbital will increase the atom and it will still what? Increase. Now, and that's on the facts about the ion. Okay, this is the fact of an ion. They say each ion contains the same number of electrons and are thus termed a collection of isoelectronic ions. The second one says they vary in nuclear charge. The radius of each ion decreases with an increase in nuclear charge. Now they say it contains the same number of electrons. Like I told you, it has the same number of protons and electrons. Electrons there, like I termed it, means charges. Okay, means the parts of an atom. So an attempt the collection of isoelectronic ions. We know what isoelectronic ions is. Now the other one said they vary in nuclear charge. Okay. The radius of each ion decreases with an increase in nuclear charge. Now they vary. When the nuclear charge comes, okay, nuclear charge makes the proton want to meet the electron and makes the electron want to meet the proton. So they are differ. Okay, they vary. Okay, they are not differ, they vary, which means they are the same, they come together. Okay, because when this nuclear charge comes, it will make them want to meet themselves. Okay, the proton wants to meet the electron for it to have a charge, and the electron wants to meet the proton for the charge to come out. And when this comes out, nuclear energy will take place. Now they say the radius of each ion decreases with an increase in nuclear charge. Why? The radius will decrease because the proton must have to reduce, okay, himself, and the electron must have to reduce itself for both of them to come together and form a bond, and that bond will bring out the charge. Now let's know what isoelectronic ions are. Isoelectronic ions are ions that have the same electronic structure and the same number of valence electrons. You know what valence electrons are? The valence electrons, you already know, are those electrons that are found in the outermost shell of the atom. So they have the same number of these electrons. They are called isoelectronic ions. When these ions have the same number of these electrons at the outermost shell of the atom and the electronic structure is the same, then we'll call it an isoelectronic ion. Now, the ionic radius is the distance from the nucleus of an ion up to which it has been influenced on its electron cloud. You know what an electron cloud is? Okay? You know what an electron cloud is? When the electrons surround the nucleus of an atom, it's called electron cloud. I've told you that before. So if you check your screen, you see the distance. Okay? The anion is now bigger than the cation. Why? Because the anion has more energy. The anion has more strength. It goes around the atom without stopping. So it surrounds the nucleus. So the distance between the nucleus of an ion to the electron cloud is called ionic radius. That is how you can calculate your radius. Because as it surrounds it, there's a distance. That distance is called ionic radius. Now, facts about the cations. Okay? They are formed by removing one or more valence electron. They vacate the most spatially extended orbitals, decreases the total electron-electron repulsion in the outer orbital, then they are smaller than the parent atom. The cations are not big, the protons are not big. The electrons are bigger than the protons. Okay? They are bigger than the protons. But in charges, when it comes to charge, the protons are 1 million times electrically charged than the electrons. Now the one says formed by removing one or more valence electron. Why? Because both of them have the same number of, they contain the same number. They have equal number. Okay? They are equal. The positive and negative charges are equal. So when you remove one electron, one valence electron, the proton will be now bigger, or we have more number than the electron. Why? Because one has been removed. Let's say they have 13. You now remove one. The electron will now be 12, and the proton will be 13. In essence, it will become a positive charge. Now, it vacates the most spatially extended orbital. Spatially means a space, just a space. Okay? It goes out from the space. When it goes out, okay, it becomes a positive charge. Now, it decreases the total electron repulsion in the outer orbital. It's smaller than the parent atom. Yes, it is smaller because it is at the middle of the parent atom. It is inside the parent atom. So I cannot put what is bigger than me inside me. I have to put what is smaller than me inside me. So in essence, since it is inside the atom, remember the cation, the proton, is in the middle of the atom. It's in the nucleus of the atom. So since it's inside the atom, it must have to be smaller than the atom because it is inside. Now, it said it decreases the total electron-electron repulsion. Let's know what's an electron-electron repulsion. Electron-electron repulsion is the principle that the electron pairs around a central atom tend to orient themselves as far apart as possible. Principle that the electron pairs around the central atom tend to orient themselves as far as possible. In essence, the protons pushes the electrons away for them not to repel. For them not to come together, okay? For them not to attract. Why? Because the proton is more charged than the electron, but they have the same number. It is more charged than. So, in essence, each charges will have to push the electrons away. Now, when it pushes the electrons away, it has now chance. It is going to have a chance of bringing out its charge and flashing out its electric charge, which is the positive. Now, facts about the anion. They say they are formed by addition of one or more valence electrons. Yes. They fill the most spatially extended orbitals. They increase electron-electron repulsion in the outermost orbital. They are larger than the parent atom. They are larger than the parent atom. Why? Because they go round the atom. They always go around the atom. So in essence, they are bigger than the atom. They occupy the outermost shell of the atom. Okay? It's like your skin. Your skin is far more bigger than your skeleton because your skin occupies the outer part of your body. Now I said it increases electron repulsion. Yes, it increases it. Okay? It increases its scattering. It increases its separation. That is why it do not have a mighty electric charge. Okay, so it decreases it. Instead of it to increase its attraction, it is increasing its repulsion. That is why it is not positively charged. It is not strong in charge. Now I say it fills the most spatially extended orbital. That space, okay, that orbital, that movement, the electrons go around the atom on a steady. So in essence, there is no space for any other thing to come. There is no space for the proton to come. So it goes around the valence orbital. That valence orbital, that outer part of the atom, it always go around there, always on a steady. That is why it's more energetic than the proton. They say it is formed by addition of one or more valence electrons. Okay? When one electron is added, it will be more charged than the proton, just like the proton. When you add one more electron, it will have a higher hand than the proton. Remember, they are always equal. Now, difference between the ions and the atom. The ions are electrically charged, while atoms are electrically neutral. I told you that the atoms have the same number of protons and electrons, so they're electrically neutral, while the ions have two different charges. Now, the second one says atoms have equal number of protons and electrons, while ions differ in protons and electrons. I told you that, and already you know that. Now, one of the most difference between the ions and the atom is that the ions is the nucleus, is the neutron. The neutron is the main difference between the ion and the atoms. That is the number one difference between both of them. Okay, the atoms have the neutron, while the ions do not have the neutron. Now, there are similarities. Okay, they both atoms and ions are composed of electrons that are exchangeable. Both of them has charges that can be exchanged. The cations can be exchanged for the anions can be exchanged for the cations, the protons can be exchanged for the for the electrons, and the electron can be exchanged for the protons. Thank you very much. We've come to the end of the class, but before then, we have to go to our exam guide to check what we have studied or what we have learned, to see the questions there, to quantify what we have learned. Now, this is 2003 question 4. They said, which of the particles indicated below represents an ion with a 2+, in essence with a 2+ charge? Okay, I told you that the 2+ charge means, this 2+ charge, I told you, is called dications. And it means 2 electrons have been lost. It means 2 electrons have been lost. So in that context, those 2 electrons are being given to the protons. So the protons will be 2 times bigger, or will be 2 times more than the electrons. Okay? If you check the answers, you will see what they gave to you. Okay? Now, check the answer. You will see that you look at it very constructively. You will know the A, we say protons are 6, electrons are 6. They are the same, which means they are neutral. There is no charge. And we say, and we are looking for a 2+ charge, which means we are looking for a dication. If you check the B, they say the protons are 6 and the electrons are 8. I told you the 2+ charge means you have lost 2 electrons. And that 2 electrons will be given to the protons. In essence, the protons will be 2 times bigger than the electron. Now, this one here says 6 and 8. The electrons is bigger than the proton, so the answer is not correct. This one says the protons are 12 and the electrons are 10. And the D says the protons are 16, electrons are 18. If you check, the protons are 12 and the electrons are 10. So in essence, the protons are 2 times bigger, or the protons are 2 more than the electron. So in that context, this 2+ gives the electrons 2 more charges. So the question there is C, protons 12 and electrons 10. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel. Hit the notification bell and share the videos to people that will benefit from it. Bye.